Hello again, ROS developers, and welcome to this ROS projects video series. If you want to learn anything about ROS, this is your channel. ROS navigation, ROS with drones or autonomous cars, everything ROS is here. Learn ROS step by step and push your ROS learning in these video series. I'm Miguel Ángel Rodríguez, and today we're going to continue in the second part on how to create your own monoped robots. So before we start, just let me remember you to visit Robot Ignite Academy, our online academy where you will find practical online ROS courses using simulated robots, no installation required. You will find a link in the academy in the video description below. And without further ado, let's get started. Okay, so we left it here last time. As you can see, we don't have the robot actuated, so the next step, logical step, is let's give it some actuators. So if you remember, we had our monoped control, which was in URDF, monoped control, and we don't have any transmissions. So let's add it right now. So how do we add transmissions? How do we add basically motors to the joints? With these handy objects which are transmissions. So if we go here and we add them, will this work? Well, it won't work because we need more than this. We need control. So we need to add these, and we need to add this element, which is a plugin. It's called Gazebo ROS Control. And we add it, you can put it anywhere you want, but normally we add this at the top. You basically need to put only one thing to this plugin, which is the namespace. In this case, normally you put the namespace as the name of the robot, but you can put anything you want, of course. Okay, so for example, we can put my monoped, but let's put it like this, okay? So, is this enough to make it work? No. We have to do extra steps. So let's just have a look at the transmissions. So the transmissions have to have a name that it's related to the joint which it actuates. It's the best way of doing it. I normally put the same name as the joint and then put trans. Yeah. Then we put the type, transmission interface, simple transmission, and we put hardware interface F or joint interface. This one is the one that works better. There are more interfaces, but basically this one's the one that works. And then mechanical reduction, if you want to make some reduction. In theory, you won't need it, but depends on what applications you might. But for us, this is more than enough. And we put one for each joint. So we have 3 joints, 2 of the hips, and 1 in the knee. Yeah, hip FE and hip AA. Okay. And that's it. So next step. Next step is, okay, we have to launch the control. For that, we have to create one launch, which is this one. This one is the example that we're going to see in a minute. But basically, we go to our beloved MyLed Robot Sims. We create a file, launch, and let me close stuff because otherwise it's quite confusing. Let me close everything and then, okay. So what's inside? So what we have to put is this. So let me copy paste and close this so we have it. So what we can see here is that we load some nodes. The first one is ROS param, and we load in the ROS param some control elements that we are going to see in a minute. Okay, Then we load the robot state publisher, which basically what it does is read from the robot description parent, gets the information of the spawned robot, and publishes all the TFs needed of the robot with the prefix and so on. So the publish frequency, the TF prefix, which is monoped in this case, and then the remap. So where do we want to put the joint states? Yeah. So it makes a lot of things, robot state publishers, but basically is the state of a robot. So how are the joints? Where are the joints? And the TF, so the transform between each of the elements. So you can know exactly where all the elements in the robot are. And finally, we launch the controller spawn, the manager, which spawns the controllers, starts them, and then makes all the PID control of all the joints. Okay, so again, this loads all the parameters for control from a file which is called monoped.yam. This one publishes all the joint states and the TFs transformations, and this one starts the control and makes the control, the PID control of each of the joints based on these parameters here. So let's have a look at these parameters. So for this, we are going to copy this folder, config folder, to our beloved package here, paste, and let me just have a look. Okay, so we open this and we see, if you have any problems, that you just have to refresh the page and that's it. So here we have monoped, which is our namespace, remember, the URDF that we stated here. Sorry, this one, no. This one's the original. This one. Monoped, this is the namespace, very important. Namespace, and then we state the joint state controller, which publishes the joint states with this rate, and we have this, which is the joints, the position controllers of each of the joints. As I said, if you have any doubts, if you want to go deeper in how to do this, please go to Robotic Night Academy, and you have a course on control, on URDF creation, on TFs, all the topics that I might not comment very deeply here. You can learn about them there. So please check it out if you have any doubts. Or leave all the comments or questions in the comments below. So here we are stating effort controllers, joint position controller, and the joint which is associated to. So if we go to here, okay, we have to state this joint, okay? So HAA joint position controller. So for example, this KFE, this one. So we normally put the same name as the joint, then position controller, the joint, the type, and the PID. That's it. As you can see, there's no integrators, there's nothing. So it can be optimized a load. But we're doing like the most basic way of doing it. So we're done? Well, nearly, because we have to change in our monoped control the name of our package. So let's have a look. So we want this one, Otherwise, it will take the one here, and we don't want that. And that's quite it, I think. Yep. So here the controller, just to state this, we are using these names are exactly the ones that we have here. So HAA, joint position controller, is this one here, and so on. And the shutdown timeout is just in case it doesn't find it, it waits for 3 seconds and then just stops. Okay, and then the namespace, very important. Okay, so now what we're going to do is, okay, we have our fantastic robot here. What's the next step? Well, the next step is launching this, starting the control. So ROS launch my legged robot sims. Then we double tab and we start monoped control. And will it work? So it can't work. Why? Because the URDF that we spawned here doesn't have the transmissions and the control plugin, so it won't work. It's impossible. So let's relaunch again the main. Be careful to get the right one. There we go. So let me change, just because that way it's easier for us. So we are going to change the gravity to 0 so that it doesn't fall. We are going to also, no, let's do it like this, because it's, that way we see exactly the steps that we have to take to do this, and then we can do it. We can do it fast. Okay, we have the world. Then we do ROS launch my let sims spawn. Okay, we have a robot. It doesn't fall because gravity is 0. Okay, and then we start monoped control. There you go. This is a correct way. You see that it controls the spawner waiting for service. It waits, and then bam, loading controller, joint state controller. It's loading all the controllers. This is very good. Controller spawner, it spawns, and when it says started controllers, that's good. That means that it worked. But it doesn't move. Well, it doesn't move because we don't send any commands. So let's send some commands, okay? So let's open a web shell here. Whoopsie daisy. There we go. Oh, we had one here. Stupid of me. Okay. So let's ROS run rqt GUI. rqt GUI. This will allow us to publish in the topics. So this is, oh, that's what I wanted to show you also. So how do we move the joints, and how will they move using this rqt GUI? So let's start this just so that we have it already there. But in the meantime, we can see that if we do a ROS topic list, we get all these topics. You see that we have monoped HAA joint position control command, and we have a command for each of the joints. So these means that if we publish here the value of the joint, the angle of the joint, we will move the joint to that location using the PID control. Okay, we can publish it here like ROS topic pub, and then put the name of the topic like HA command, whoops, sorry. Okay, std float, and then double tab, and we put the value. Let me just show you here if we can see the robot. Okay, so for example, we put I don't know, like 1.5. You see that it's moving there. There you go. If we put 0, it's working perfectly. You see that it's trembling. That's just because the control, we can fine tune it much more. Let me just pull him a bit up so that it's not touching. Okay, but this is very cumbersome. So what we're going to do is go to this graphical tools that we have here, and we do go to plugins, topics, message publisher. Okay, we get, for example, I don't know, the knee one, yeah, that one. We'll put like I don't know, like 20 Hertz, and you see the topic is this one, and we can put mathematical functions divided by 20. So basically this will send different values to this topic. To see this, we just have to go here, and we are going to do a ROS topic echo. Okay, and we go here and we activate it. There you go. Now, so you can see that it's publishing exactly the values that are meant to be published, and it's moving the joint. Yeah. As you can see, because we have a very basic control, it trembles and makes very query movements, but basically we have this. Okay, so we have a robot moving. So we stop it, and we have the robot here moving. Okay, so that's it. So more things that we can do. So we can go to here. And okay, we have now a robot that moves. So basically what we have to do is add this to the main launch, so that we don't have to launch the control and everything every time. It's very tiresome now. So now we just have to close stuff. And you see that it lost the control, so now it's there. Okay, let's close this. Let's close this. And we are going to relaunch, but in this case now we are going to launch with a spawn and with the starting of the control. So you can see all the messages: start the controller, joint, blah 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 blah. So here we go. Whoops. What happened here? Oh, you see, now we launched that one. So the example one is white. So there you go. So you have to be careful with this. Okay, so we have this. Fantastic. So now what can we do? Well, basically the only step left now is to add the sensors needed to make to move around. So we need 3 basic sensors. 1, odometry. We have to know where the robot is. Why? Well, because some programs like softwares like this one, Tower and so on, need the odometry. They need to know where the robot is to know what's the next step. Okay, because the terrain is different and so on. And also in OpenAI, you need it because you have to validate if the robot is moving to the right direction or not, and do the compensation for that, and do the reward if it's moving in the right direction, or not give the reward if it's moving in the opposite direction. This is one. Then you need the IMU to know the orientation and so on, also for navigation, for movement and so on. And the third sensor is the contact sensor, which has to be in the tip of the leg, in the foot, to basically tell him where is stepping, how hard is it stepping, and in which direction, because maybe the contact is not like in the center, like here, just centered, but it's like in a side. This means that maybe the movement has to be different. So all these situations have to be accounted for. So let's add the sensors. Luckily for us, in Gazebo, it's really easy to add sensors. You just have to, let me close the things that we're not using now. Yeah, so we have our beloved URDF, and we go to the example, and we add extra. So we just have to add extra plugins. The first one is the P3D, which essentially what it does is you give him a link, and it publishes the odometry, which essentially what it does is get the position of the 3-dimensional elements in the simulation and publish odometry. That's it. So let's copy and paste. Okay, this is one. And with the update rates, there's nothing. The topic name, you can put any name you want, but odom is the classical one. You can give some Gaussian noise if you want, some offsets. I mean, this depends on the configuration. We don't need that. Okay, this is the first sensor. That's it. There's nothing special about that. The next one is, let's add the IM because it's easier to explain. So we add the IMU more or less. It doesn't matter where you put it, actually. So here we have it just beneath the joint of the contact sensor. So we'll put it here. Okay, this is the same. You just load this IMU plugin and you put the namespace, important, the topic name also, the service, how the service will be named because it generates the service. This is the important part, the body name. So which is the link where the IMU will be like plugged, like stuck there. In this case, it's very obvious, is the base, is the cube, the blue cube. And then some Gaussian noise. In this case, we are not going to put anything. And then the update rate. This is to simulate like the real IMUs that you might use. So if you bought an IMU that has a 20 Hertz rate of publishing, then put this here. If for example, your IMU is very crappy and very bad, then maybe 5 or 1, it's more than enough, okay, to simulate the real sensor. And then always turn it on. That's it, because you can turn it off and on depending on through the service and so on. Basically, we have that. Then The one that it's a bit tricky is the contact sensor. I'll explain you why. So we add it here. Okay. As you can see, it's a sensor. It's not a plugin per se. It's not something. And then you have the plugin here, which is the bumper one. And there are some tricky little things. So basically the only tricky thing is this, that it's based on a bug that this plugin has. Because when SDFs, URDFs, like this URDF, is transformed into an SDF. And this SDF is the one that it's loaded in Gazebo. The problem is that when it's transformed, this sensor, for some reason, the collisions are modified. And are modified in a way that if you don't put this like this, so it won't work. Okay. So what is like this? So let's have a look. Lower leg. Let's have a look at the lower leg. So let's, just to validate things. Okay. Okay. So as you can see here, let me close this. So as you can see here, the name of the link where the contact sensor will be linked to is this sphere that it's called lower link contact sensor link. Okay. If you don't put any names here, so here you can put name, I don't know, my collision contact. Okay. You can put names to the collisions. If you don't put anything, automatically it's named lower leg contact link collision. Just like this. And then you have to put 1 here. Why? I don't know, because that's the bug and you have to put that one. So if you want to know exactly the name that it will put, you have to convert to SDF. Yeah, and see exactly. But basically is the name of the link, and then you put this _1. Yeah, I know it's a bit buggy, but the plugin is like that, and I have to tell you exactly how to use it so that it works. Yeah, I think they are working on that, but it's not, I don't know when it will be fixed. Okay, so there we go. So now we have the contact, we have the IMU, and we have the, which one? The odometry. Yeah, just comment this also, the bumper topic and the frame, which is lower leg contact link. Okay, yep. So now we are going to launch again. And let's have a look to the topics now. Okay, we have much more topics now. We have lower leg contact state. Let's have a look. ROS topic echo and what is being published. So there's no contact. Let's change the gravity and let's put like -0.5. Let's relaunch again. Okay, it's falling. Now, obviously, if you don't have gravity, there won't be contacts. Now there's contacts. So let's stop it just there. So it gives you a lot of information, like the force, the torque, the contact positions, everything. Yeah. And it's basically the contacts in this little sphere. Okay, this is very useful for locomotion. It's vital. Then another topic would be ROS topic list. And ROS topic echo, the IMU data, which, well, basically it's telling us that it's more or less turned in this x-axis, but it's a quaternion, so take it with a grain of salt. But basically the idea is that it's more or less turned on the x. Yeah, we could say that, I don't know. Yeah. And finally, ROS topic echo other, which we have, well, minus y. Let me see. Well, yeah, we could say, yeah, if that this is x. So the IMU was telling us that it had turned around this axis, which makes sense. And the odometry is telling us that more or less is if y positive is this direction, so probably the opposite direction to where it has fallen. So this is -1, yeah, more or less. Yeah, so -1, yeah, we could say that, yeah, it's coherent. And in the x, it's not in 0, so it's like a third. So 0.3, yeah, it's coherent. Okay, so we have sensors, we have everything. And one last thing, yeah, let's do one last thing. So to test more or less the movement of the robot, it's good to have a script that moves the joints around. So what we're going to do is create a folder, scripts, and inside it we're going to put this joint publisher, copy, and we're going to comment right now. Yep. So we can close this, and let's have a look. It's a very simple class, but I think it's very useful. So what we are doing here is when you launch this Python, it creates this joint publisher class object, and you state the rate at which it publishes, and then you start the loop. So this class starts three publishers for each of the joints, yeah, type float. How do I know that? Well, because you can do ROS topic list, ROS topic info, monoped, for example, and it will tell me the type, so the package and the type of the message, and then who is publishing, which is well, in this, sorry, it's subscribed by these guys, subscribers, it's Gazebo, yeah, and the one who publishes is the one that say, hey, publish and move, and Gazebo will read that and then move the joints accordingly, yeah. Then we add it to this array so that it's easier to then iterate through all the three publishers. Then sorry, this we don't need it. Yeah, we don't need it. So let me get rid of it so that it doesn't mix things up. So we created this move joints, which basically gets this array, iterates through this array, and gets the joints array that was sent and gives the value for each of the joints, and then publishes like that in this publisher, and this will move the joint, yeah. And then this final function, which is start loop, which is a loop that alternates between position 1 and position 2, which is position 2 is everything 0, so more or less like this, and This one, which is the hip doesn't turn sideways and it just flexes the leg. Yeah. So now once we have that, we state the rate, which we state here. We state the rate that we state here. So we state the rate that we state here, and we alternate between position 1 and position 2. Yeah, it's not something very strange and so on. So just let me go closer. Then we do ROS run my legged sims, and we do the join publisher. There we go. So as you can see, it's moving around, alternated between that. If, for example, I can stop it, and there you go, because we didn't give a lot of time. So if we, for example, publish every 2 seconds, and then we launch it again, there you go. There you go. Okay. So this now you have to calibrate it so that you can do very fast movements. For that, you have to go to your various places you have to touch, but that's like time consuming because you have to calibrate it correctly, otherwise it will go crazy. But essentially what you have to touch is 2 things. You have to go to each of the joints, and you see that you have different velocities here. So what we have to do is we change the speed to, I don't know, like 10. Yeah. Let's change this to 10. And we relaunch again. So we stop this. And we relaunch again. So basically this, what it does is the maximum velocity that a joint can get. So 1 would be 1 radian per second, which is, it's quite a lot, but it's not that much. So 10, it's quite fast. Okay, now we launch this again, but we change the speed. Let me just launch it like this for the moment. So once every 2 seconds. There you go. So you see it's much faster to go, but we have to calibrate the PIDs, because you see that when it gets to 0, it oscillates a lot. So this, you have to calibrate it, but that's another story. So and that was it. In the description of the video you will find a complete course to URDF creations and also to control in Robotic Night Academy, so please check it out. If you had any doubts or you want to go deeper in this subject, if you didn't like the video, please give us a thumbs down, but if you like it, thumbs up, and consider subscribing because we publish videos every day. Please leave comments, and I would love to see all the projects and things that arise from this. Also, if you create simulate versions for the quadruped or for the biped, please leave it there, create a Git and share it with the community. And yeah, that's quite it. So, hasta la vista.